let's get started with the next talk. Over to you, Ritu and Kamini for Kiosk Engineering.
Thank you, Jocelyn, and thank you everyone for joining us all over here today. We are delighted to host you today. So I, along with my co-speaker, will be helping you all with delivering a talk on Kiosk Engineering using Kiosk Mesh tool, which is a very in-demand tool nowadays. So before we get started, I would like to introduce myself, and then maybe Ritu, you can go next. So I'm Kamini Pandey, and I'm working with ThoughtWorks for last 2 years now, and I've been into this industry for more than 6 years now. I expertise in creating frameworks and have worked on multiple tools and technologies related to testing. So yeah, that's pretty much it about me. Over to you, Ritu.
Thank you so much, Kamini. So it's been a year since I have joined ThoughtWorks, and I'm currently playing the role of a QA, which is quality analyst. To wrap up my experience in a nutshell, prior to this, I have had experiences in operations and sales strategy across companies like Amazon and Byju's. It was mostly internship, so I started my IT career with ThoughtWorks itself. Throughout the past 1 year, I have had experiences in various automation frameworks coming to UI automation, mobile testing, performance testing. But lately, I've come across this concept of Kiosk engineering, which seemed quite intriguing. And to top it off, a tool which is amazing to work with, which is Kiosk Mesh. And today we will be we'd like to kind of share the experience with you. Yeah, Kamini, you can start.
Thank you, Ritu. So before we get started, I would like to understand is anyone aware about or heard about this term Kiosk engineering here? Yes, no? Maybe you all can keep answering the questions which we generally ask in the chat or in the Q&A. So if you have not heard about it, this talk will be definitely going to be very helpful around understanding what Kiosk engineering is, and we'll also be talking about Kiosk Mesh. So without a further delay, let's get started. So what to expect from this talk? So these are the table of contents. We'll be talking about what introduction around Kiosk engineering, what of Kiosk engineering, how to perform the Kiosk experiments. Moving ahead, we'll talk about CIA, threat modeling, how and why of threat modeling. We'll talk about how we can secure our applications and how we can implement threat modeling using Stride. We'll also talk about various Kiosk engineering tools available in market today. And then moving ahead, Ritu will help us with the understanding of around Kiosk Mesh and the demo part. Later in the later half, we'll talk about the demonstration and followed by Q&A sessions. So yeah, this is what we are expecting from the next 1.5 hours. Coming on to the very first content, what is Kiosk engineering, right? Yeah. So it is so had happened that it could have happened with all of us that everything which is working absolutely fantastic on our system in our lower environment, in our test environments, and the same is not working sometimes in production environment, right? So we all must have come across through these issues in our lives, right? So why exactly it happens? It can so happen that the failures or the issues which have been identified in the production has not been tested properly, or maybe the conditions which are being there in the failure scenarios which are there in the production may not be occurring in the lower environments, right? It could be there could be multiple reasons. One such reason could be the configurational changes, or there could be some data or information mismatches, right? So all this can happen. And these can lead to severe security breaches, and all that stuff can happen with your application. So how do we deal with this? And how do we identify that our system is working fab in both the environments, in the testing environment as well as in the production environment? So the answer is Kiosk engineering. So if we go by the principle of Kiosk, it says that Kiosk engineering is the discipline of experimenting on a system to build confidence in the system's capability to withstand turbulent conditions in production. But why do we want to test anything in production? If we all are always advised to do the production, not to touch the production, right? And to always work on the local environments. This is because in a statement, Netflix said that if you wanted to check the vulnerable areas, or if you wanted to fail or identify failures, you'll have to fail constantly, right? Then only you'll be able to identify that why this failure had happened, why this particular data leak had happened in the production environment. And this is what chaos engineering tells us, right? So this is the scenario, and by using this particular chaos engineering, we can identify all those turbulent conditions which are available in the production environment. How we can do it? So first of all, we'll have to identify the chaos scenario, what exactly we wanted to do, right? What is the normal behavior of any system? Once we have identified the normal behavior, we'll have to perform the chaos testing into the production environment. We'll have to run some experiments in the environment. And then post running those experiments, we'll analyze the results. Why do we want to analyze the result post performing? Because once we'll analyze, we'll be able to identify that why this particular issues had happened, and we'll be able to fix them before time, right? Once we have analyzed the results, we'll try fixing them, and which will overall result in improving the resiliency of the system, right? So this is why chaos engineering came into picture, and this is how it can be very helpful to all of us. Now, though we know that what chaos engineering is, let's talk about and let's see the history of chaos engineering. So Netflix in 2008 began chaos engineering, and chaos engineering actually get matured at Netflix itself, because in 2010, Netflix again launched Kiosk Monkey and Siemens Army. There were some technical people also got involved in the chaos engineering part, and then Gremlin was born in 2016. In 2017, Kiosk IQ born KioskCon, and in 2018, 2019, and 2020, there were 3 different books which were launched related to chaos engineering. In 2018, Kiosk Monkey for Spring Boot was born. It was launched, and it is a very helpful tool for chaos engineering. In 2019, Kiosk Mess, which is a very wonderful tool, and which is a very user-friendly tool, which we will also be discussing about, that got launched in 2019. So this is how chaos engineering got evolved, and from 2008 to 2020, and still evolving nowadays. Now that we know that what is chaos engineering and what was the history behind it, let's understand that why do we want to perform these experiments? Why it is required to perform these chaos experiments. So the very first thing, the first point which says that it reduces system and application downtime. How it can reduce the system and application downtime? Because it can happen so that once we don't have any failure scenarios in production, our application will not go down, right? Our application will not crash. We already know all failure scenarios are already tested and the fixes for those issues has already been taken care. So this overall helped in improving the system and application downtime. It actually reduced those downtimes, and this is what leads to the second point. It says that it minimizes revenue loss due to downtime. But how a system, by performing chaos experiments, these revenue loss can be minimized? This can happen so by once the application is up and running, always available, the user will be able to identify or to use that particular product for a longer period of time. And that's the reason the company will generate more revenue. So the more resilient system, more user trust is there, the more revenue generation will be occurred, right? So this was around minimizes revenue loss due to downtime. The third point says improved user experience. If at all I get a chance to work or to use any product or an application which is getting crashed every now and then, I am not going to use it. I mean, at least none of the users will prefer to use that particular product. If take an example of booking a cab or to commuting somewhere, or for ordering our foods. So this, and if that particular product is getting crashed every now and then, how will that user experience get better, right? So if the kiosk experiments has already been taken care and already been performed in production environment and with on that particular product, this will improve the overall user experience. Now coming on to the next point, it prepares the system against unexpected failures. Now, though we know that our system is already tested behind all those scenarios, which the real-time scenarios, right? So all those possible failure scenarios has already been tested, and all the information we have already received by performing those kiosk experiments, we will be able to fix those and will identify the root cause of it. And maybe we can also work on improving the resiliency of the overall of the system, right? So it prepares the system against unexpected failures because we have already done a lot of testing, a lot of experiments has been performed. So this will help in preparing against those turbulent conditions, right? The next part talks about it improves confidence in the system. Now though we know that we have a zero or less minimal downtime of the application, our revenue is working absolutely fantastic, and the user experience is already improved. This actually overall build the confidence in the system, not only to the business, but also to the users. Users are now more reliable on or more relying on this particular product, that this actual product is working absolutely fantastic, right? So this will, by performing all these experiments, this will improve the overall confidence in the system. Now, well, now that we know that what chaos engineering is and what the history of chaos engineering and why do we want to perform chaos experiments, let's see a case study where a smaller, a very minimal IT failure had created a lot of chaos. So this has so happened with British Airways in 2017 that their web check-in functionality was not working. But what could have happened if any auto web check-in functionality is not working? There still can be a process of manual check-ins, right? You're thinking in a exactly right direction. And this is what anyone could have thought of. I also thought of the same way, but then what will happen if the number of customers or the passengers are very high? This has happened with British Airways when there was a IT failure, their web check-in was not working, which affected more than 75,000 passengers to be stranded and facing flight cancellations because British Airways was not able to handle the situation for more than 24 hours. And they had to do multiple flight cancellations. And there was a lot of chaos happen at the Heathrow airport. All of the passengers as well as the employees of the British Airways were facing difficulties, right? So what all this chaos that has been created with British Airways, what exactly had happened behind the scene? Nothing, just a company has just lost 80 million pounds behind all these scenarios. And in addition to this, they also have lost the customer trust. Now the user don't trust the system anymore. They don't prefer booking their travel tickets with British Airways anymore. At least I would not be preferred to do these tickets, right? So why this all happened? This was all happened because of the unavailability of one of the normal web check-in functionality or one of the components from their website, which was not working. So we saw that a smaller failure can create big impacts. And this is what level of impact we are talking about. A very minor security breach or a minor security incident can create a huge impact on the company as well as to the user and to the user trust as well. All right, moving ahead, we'll talk about CIA. So what is CIA? CIA is actually a CIA triad where we talk about confidentiality, integrity, and availability of any system. What happens in confidentiality, integrity, and availability, and why do we want to talk about it even? This is because these are the major security properties. Whenever we go for any security design discussions, we should always consider these properties. Apart from these three, there are three more properties of securities, which we'll talk about in the later discussions on the later slides. But first, let's focus on what CIA triad is, right? So the very first talks about confidentiality. So what is confidentiality? If we go by the term, it says that if we go by the dictionary definition, it says that privacy of information or something which is private to you, right? Which is confidential to you. So what will happen if something is some unauthorized user has access to that confidential data? They can there can be security incidents happen, and it has happened with a lot of companies, with a lot of users, with us as well. Somewhere or the other, we have been also there has been a confidentiality breach happened with all of us as well, right? So here, what is the exact terminology behind it? That confidentiality means prevention of unauthorized disclosure of information. The data or the information which should be available, should be visible, should be located only to me, is now visible to each and everyone out there in the world, right? So it should not happen. So while designing any system security and while designing any system, we should always consider this confidentiality terms and how we can improve it, right? Now the next term comes talks about integrity. So what integrity means, maintaining and assuring that data cannot be modified in an unauthorized or undetected manner. So let's take an example and let's understand this integrity with an example that I wanted to book a flight from India to maybe Delhi to London, which cost me around 60,000. Now, what happens if I go onto a booking agency website and see that this particular booking amount has been reduced to 600 INR? I will go quickly and book the tickets because I had been onto the website to book the tickets, right? And if the prices are as low as 600 INR, definitely I would go without a blink of eye. I'll try to book that particular ticket, right? So integrity tells us about that only. So that exactly what happens when someone else modifies the data in an undetected manner. Some unauthorized user has got access to maybe to that application system through performing some attacks or through any mechanism, and they have just changed the data point of that particular booking application. They have changed the booking amount of that particular fare, right? So what has happened to company and users here? So maybe possibly I was able to successfully book the ticket, and I have already planned with the other tickets and all. Now the company has been aware that this particular ticket has been booked and only 600 rupees, right? Now, if the company is ready to get or to be onto that part where it actually ready to get the revenue loss of more than 99%, they'll easily accept that booking. And if not, they'll cancel the booking. What will happen if they'll not cancel the booking? They'll suffer a loss, right? And if they'll cancel the booking, there will be a customer trust which will be lost, right? If their system is not that capable enough and there are some integrity or security issues happening with the system, I would not prefer to book any travel tickets with those softwares, right? Or with those agencies. So this is what integrity tells us about, that integrity means maintaining and assuring that data cannot be modified by any means, by any unauthorized or undetected manner. No one can be able to modify that particular data. Coming next, we'll talk about availability. So we saw the case study of the British Airways, and we saw that what kind of chaos it has created when it went, the web check-in was not working, right? So what could have happened? The system was not available, the web check-in was not available. It means every product should be highly available and should be highly resilient enough to withstand any turbulent conditions, right? Availability means information should be readily accessible for the authorized users. It should be available up, it should be always available up and running. Your product should be highly resilient, highly available. Then only you will be able to sustain in this market, right? So this is all about CIA triad. Do we have any questions here? No? If you have any questions, feel free to drop in the comments. All right. So before we move ahead, let's get onto one poll question. Shishir or Justine, can you please help us with the poll questions? Is it available now? Maybe because it is not visible to me.
Yes, it is available.
Can we get the answers and share the results if everyone has answered the question?
Yeah,
All
so
right.
it is done calmly. Yeah.
All right. So we asked about the privacy of information. Was it the same poll question launched?
It was about the type of attack
Okay.
case study went through.
All right. So we went through the one of the case study where we identified that the system was not available for our one of the British Airways airline, right? And we identified that there were 4 different attacks which can so happen with the system. So were we able to answer the question? In case we do not have idea about what kind of attacks or what sort of things can happen with the system, or what all type of security attacks are available there, you can go onto the OWASP website, and it will be very helpful for all of you to get more information around all the security incidents or the security attacks which can so happen. So yeah, that was about it. Coming on to the next poll question, can we please launch that? All right, so though we know about the CIA triad and we talked about what confidentiality is, what integrity is, and what availability is, can we answer the question that where does this privacy of information falls into picture? Do we have some responses, Ritu?
Yeah, so we have 91% for confidentiality and we have 9% for availability.
Okay. So confidentiality, so privacy of information is basically associated to confidentiality, wherein the privacy of information is located, and we talked about it in detail, right? So moving ahead, we saw there were multiple security incidents happen, security threats happen. We identified few of the security vulnerability areas of any application. So any idea that how we can prevent these security mishaps in our application? So the answer is threat modeling. With the help of threat modeling, we can actually identify and we can prevent these security mishaps with our application. So let's talk in detail about what threat modeling is. So threat modeling basically works to identify, communicate, and understand threats and mitigation within the context of protecting something of value. What is that? So threat modeling is basically a team exercise wherein we all, be it the business stakeholders, BAs, developers, QAs, everyone in the team will perform an exercise in order to identify the security and the vulnerability areas of our application. The key objectives of threat modeling is the first is identify security requirements. In order to protect something, we'll have to identify first what exactly we wanted to protect, and that's where the requirement phase comes into picture. We'll identify what do we want to protect, and we'll come up with our requirements. Once we are sorted with our requirements, we'll move ahead with pinpointing the security threats and potential vulnerabilities. In slides going ahead, we'll also talk about in details that how we can conduct these threat modeling exercises. So we'll first pinpoint the security threats and potential vulnerability areas. Once we have identified the threats, now we'll quantify these threats and vulnerability criticality. How we can do it? We can do it by using a magic quadrant where it talks about the probability of occurring those threats and the priority of that particular threat, right? So with the help of that, we can quantify. And once we have quantified and identified all those threats, we'll prioritize the remediation methods. So how soon we wanted to fix them, or how soon, what is the priority and probability of occurrence of those threats. So these are the key objectives of threat modeling. Moving ahead, why do we want to do threat modeling? We are all talking about security, we are all talking about chaos engineering, but why do we want to threat modeling? The very first thing, it says that it is better to find security flaws when there is a time to fix them. Let's say we have a release plan and we identified few of the security flaws in our system. Will it be a better time to fix them? Or it can so happen that while fixing, we identify more, or maybe we uncover more security flaws of our system, right? So it's always better to find all those security issues before time, so that while going for a release, we can release a bug-free or a security which have a higher secure applications in production, right? So the very first point tells us about that. The second point says it can save time, revenue, and reputation of your company. We just saw the case study of British Airways. It would have, if they have performed these kind of scenarios, these possible scenarios in production before, they would have saved their time and the customer's time. The revenue would have not lost. The 80 million pounds revenue was lost due to that incident, and the reputation of that company would have also been saved, right? So it is helpful in saving all these three things. Coming on to the third point, it says to build a secure application. But how do we want to, how we will build a secure application? By only doing threat modeling. It can so happen that we have identified all the security flaws of our system, and we have uncovered all the security, all the threats of our assets. So the overall product which we'll be releasing, that will be a secure application. So in order to build those secure application, we should always go for a threat modeling exercise. Coming on to the 4th point, it says to bridge the gap between developers and security. So it is a possible scenario that developers are developing the application from their own development mindset, and security professionals are testing the application from their own mindset. And there can be a huge difference in their mindsets, right? But there is a possibility that when developers are developing, if they are already aware about all these threats, all these areas where those threats or those issues or those security issues in the application, they may be providing, or they may be modeling that particular application in such a way that those security issues will not happen with the final product, right? So that particular knowledge gap is being already covered by after using or after doing this threat modeling activity. So it says that to bridge the gap between developers and security. Now, coming on to next point, once we have already seen the objectives of threat modeling, and it says that to provide remediation methods and to provide to identify threats and all that stuff, right? But how we will check all these and validate these in long term? So threat modeling exercise also provides document of all the identified threats and rated threats. I also talked about the priority and probability of occurrence of those threats. So it can so happen that there before release, we wanted to fix all those high probability and high occurrence, high priority and high probability of occurrence of those threats. And there are few threats which are left, which will be going off and which are of lower priority, right? So by using these documents, we can identify all those rated threats, right? So by doing this exercise only, will be getting that document. And the last thing says it offers knowledge and awareness of the latest risk and vulnerabilities. There is a possible scenario that a person has left the company and some other developer or maybe some other developer has joined onto our project. If they're already aware about what latest risk and vulnerabilities are there in the system, they can identify and they can work towards fixing, and not only just fixing, towards bridging that particular and to filling that particular areas where most of the security issues are there, right? So threat modeling is essential, is important because of not just because of these 6 reasons, but there are many more things which are there, right? Let's go on to the next slide. Before that, is there any questions? If you do have any questions, please feel free to ask in chat or in Q&A. We'll be happy to answer them all. All right, now though we know that what is threat modeling, why do we want to do the threat modeling? Let's see how to conduct threat modeling. So threat modeling, in order to do that, we'll have to identify what exactly we want to do the threat modeling of. So let's say we wanted to do a threat modeling of our own application. So that application is identified as an asset to us, right? Now, though we know the application, the asset, will describe the architecture of the application, because it can so happen that there are multiple components available, which is useful for and which are there in building that particular application. So while describing the architecture, it will help us to identify all those components. Once we know the components by use of this those architecture, will decompose the application, meaning we'll try to break that particular architecture into different components so that we can identify number of threats and we can uncover all the security issues with every component, and we can identify majority of threats of the system, right? So the third step says decompose application. Sorry. And then identifying threats of each of the component. Once we have identified, we'll document that threats and rate that threat. Documenting will take place while identifying, and post-documenting, will rate those threats about priority and the probability of occurrence of those threats. So this was about how do we want to conduct threat modeling. Moving ahead, we'll talk about Stride. So we always wanted to have the secure applications, and to ensure that our applications have all those 6 properties which I talked initially, have those 6 properties with our application. We'll talk about in details in this particular slide. So Stride is a mechanism or is a model which is helpful by which we can do threat modeling. So Stride is one such model. How it came into picture and how it was discovered. So in 1990s, 2 Microsoft developers have introduced this Stride model, wherein it was aimed to model the different security vulnerabilities in any application, and also to identify or to how we can remediate all those 6 properties, all those security properties in our application. So Stride talks about that. Each term is related to one of the element, and we'll talk about those elements, right? Just a moment. All right. So the very first term says about spoofing identity. S stands for spoofing identity, wherein illegally accessing and then using another user's authentication information. So we all must have received various calls, emails, messages around that we have won a lottery from some organization, or from, to be very latest, from KBC, right? And Amitabh Bachchan is on call, and they are asking for our account details. Do you think that these calls are genuine, or these details will be utilized or will be not utilized by them for performing some malicious activities? The answer is no. These are fake. These are truly fake, because and that's what spoofing identity talks about. You are pretending to be someone else and trying to get the excess of information on, and then later utilizing that information in order to perform some malicious activity. So spoofing identity talks about that. Now, coming on to the next term, which is tampering with data. We saw I talked about the travel agency ticketing system, right? Where the price of the ticket got reduced to 99% off, right? 99% discount was given to the users, to the customers. Now, what could have happened behind? The data was actually tampered. There was a malicious modification happened with the system, and unauthorized changes, which was not known and which was not authorized to do those activities. So tampering with data talks about that. Coming on to the next part, which R stands for repudiation. Repudiation, we can say that, let's say someone has stolen something from your house. How are you going to trace it, or how are you going to get the details of that person who has stolen something from your house? It may be through someone can inform you about him or her, or maybe someone can get the CCTV scans for the person who has entered your house, right? So all this talks about repudiation, denying that. So non what had happened in the backend, right? So maybe there is a possibility that user who has done some malicious activity on your system is now denying that it has not happened. The same, so repudiation talks about that, deny performing any malicious action, and we will not be able to trace it back. There is no logging mechanism, and by any means we are not able to identify who has done this particular malicious activity, who has done these attacks. So this is all about repudiation. Coming on to the next point, which talks about information disclosure. So it says exposure to information to individuals not supposed to access. Let's understand this with an example. I go on a holiday and I post a picture of me, and I've posted it some that it will be available only to people who are in my friends list. But somehow there are some people who have done some sort of attack, some sort of hacking, and that particular image, that particular post is now public, is now available to everyone. So now everyone knows about my whereabouts. Where am I? What am I doing? Where I'm going? And these all can lead to some or the other activities which can cost me huge, right? This information which has been disclosed to someone who is not authorized to get that access, this can cost me a lot, right? My security can be breached at that point of time, or anything can happen with me, right? And I'm not aware that who all are there, right? Because the number is huge, the number is infinite, that I don't know who all have seen that particular information or particular post. So information disclosure talks about that only, that exposure of information to individuals not supposed to access. People who were not in my friend list, they were not supposed to get the information that where am I, but now they are known by after some attack had been happened on my Facebook account. Let's talk about the next term, that is denial of service. So we saw the British Airways case where the web check-in was not working, and it actually denied the service to all the valid users. What has happened in background? the system availability was gone for a toss. The system reliability was gone for a toss, right? So this is what denial of service talks about. Deny service to valid users, and it can create threats to system availability and reliability. System may not be available. Maybe you're trying to book some website, on some website, or you're trying to book some application or some book on any of the website, e-commerce website, and you're not able to do the payment part, right? What is going on in the background? The company is actually the revenue of the company is getting minimized, right? So this was what denial of service can do in a broader picture. If we talk about, let's come on to the next point, which is elevation of privilege. Let's understand this with a very basic example, wherein I am using a State Bank of India banking application, and the other person who is the employee of that particular organization has also some logged in credentials, like we all of us have, right? Now, somehow I have got the privileged access, the elevated access of that particular employee. Now I can not only see my data, but also all those critical information which is available, which was only supposed to be available for that particular employee of that organization, and not to different users. I can get access to all the credit card, debit card details, account details, everything, every critical information which was supposed to be available only to the authorized users. Just because I have performed some activity and I've got some privileged elevated access, now I can do whatever I want to do with that particular data, right? So this is what exactly happens in elevation of privileges. Unprivileged users, I was unprivileged. I was not supposed to get that particular privileged access of that application, but still I got them, and I compromised the system. Maybe I can release that particular data to anyone out there, right? So effectively penetrated and become part of the trusted system, because now I know I have logged in with the credentials of the employee. I got the access of the information, and the system is trusting that that user is actually logged into the system. So this is what Stride talks about, and these are the 6 different properties or security properties aligned to Stride. So yeah, that's pretty much it about Stride. Moving ahead, we'll be demonstrating around Kiosk Mesh, and Ritu will be helping us with that. So before we move, do we have any questions with us? If so, please feel free to ask them in your in the Q&A and in the chat box as well. We'll be happy to answer them. Over to you, Ritu.
Thank you so much, Kamini, for covering the concept of chaos engineering, threat modeling so well. So I'll now be sharing my screen. Just let me know if it's visible or if there are any issues.
It's visible. You can go ahead.
Cool. So for this experiment, we will be exploring around Kiosk Mesh. So leading on to the British Airlines massacre. So if such a scenario happens in cases where not only money is at risk, but also life, like support, if you have some life supporting applications, right, where every second of downtime can cost a life. So we can't happen scenarios like this happening. So we will be playing around in this experiment around a very important CIA tried feature, which is known as availability. And for experimenting around it, we'll be using the tool which is known as Kiosk Mesh. So if any of you have in prior experience of working with Kiosk Mesh, you can mention that in the chat, or yeah, whatever thoughts you have on it. Meanwhile, I'll just give you a quick intro around what Kiosk Mesh exactly is. So Kiosk Mesh is an open source cloud native chaos engineering platform, which is used for orchestrating chaos scenarios on Kubernetes cluster. Now you will get a bit more idea on the Kubernetes cluster and how it exactly works in the next slide, where I'll be going into the architecture. But as of now, we need to know that it is used for orchestrating chaos scenarios, and it can replicate scenarios which can occur in development, testing, and production environments, and can help you in finding potential problems in the solution. in the system. So yeah, the thing is that now that we know what Kiosk Mesh exactly does, the thing is that, why should we go for Kiosk Mesh? So one of the main features for kind of building reliability is authenticity. So suppose we have a lot of shopping websites in present scenario, we have Amazon, Flipkart, and a number of ABC, XYZ websites. But we generally, if we have to buy something, we go to Amazon, Flipkart, or our reliable websites. Why? Because we already have used it and we know that it's a trusted brand. Same thing happens with Kiosk Mesh. It is used by a lot of big organizations like Tencent. It also have layered of security support. So it is a very secure application to work with. And it has a good support over all of the basic kiosk, faults that you might be wanting to simulate. So whatever you would want to play around, mostly you will be having it here. And for doing that, you would be having a great amount of options. You can work with the config YAML files, or you have a very, well-suited visual component in Kiosk Mesh, which we'll be learning in the further slides. So you have full automation enabled, and you can kind of administrate a lot of chaotic scenarios and view results graphically explained very well. So also to add on, it is an incubating project by the CNCF team. So if you have any doubts and any queries, you would be having a good community to support. So yeah, probably if you have any doubts, you'll be finding the answer very easily to it. Coming on, the architectural overview of Kiosk Mesh. So the Kiosk Mesh architecture mainly consists of three main parts, which is the Kiosk Dashboard, the Controller Manager, and the Kiosk Daemon. The Kiosk Dashboard is the visual component of this entire architecture, which is used for manipulating and kind of viewing your experiments. So what I mean by manipulating, so suppose you have an experiment and you want to halt it for a bit, maybe you want to work on your application, so you can do that. Also, if you want to kind of view the current experiment which are ongoing or the result of the prior experiments, you can do that as well using Kiosk Dashboard. The next part is Controller Manager. So it is like the chief logical unit of this Kiosk Mesh architecture. So what happens is that it is used for scheduling the application, scheduling the Kiosk experiments, and also managing the same. So now for administrating Kiosk experiments, you would also be needing the support of the chief executive component, which is the Kiosk Daemon. So Kiosk Daemon is present in all nodes of our cluster. Now let's understand the cluster model a bit more to understand what Kiosk Daemon exactly does. So currently, when in the world of microservices, I think all of us, are very well versed with the advantages of using containerized application. So when you have containerized your application using PV, Docker, or Minikube, you would be needing an orchestration platform, which would be kind of managing your clusters and managing the way your application works. If anything goes down, somebody should be there to kind of make sure it starts up and there is no downtime. So for that, Kubernetes is one-stop solution. So what happens is that in Kubernetes, you have clusters. In clusters, your containerized application along with its binaries are wrapped in the pods, which is the smallest executing component in the Kubernetes cluster world. And those pods are present in a node. And node is just like, normally we have our VMs or we have our normal OS. So it's similar to that. So kind of you're hosting your application on the node, and this entire part makes for a Kubernetes cluster. So what happens is that you would be kind of simulating any of these faults that you want using your YAML file or your Kiosk Dashboard. How to do that, we will understand later. So you'll be using this too. And then the Kiosk Daemon would be kind of hacking into the namespace of the pods and helping you with scenarios like access to network or IO. So if you want to induce a network loss or a network delay scenario, probably this would be helping you a lot. Again, I mentioned another term, which is namespace. So what is namespace? So the thing is that suppose Kamini and me, we work as part of the same team, right? So what the application that we're working on, each of us is kind of logically independent, but we're currently contributing to the same project. So what would I do? Would I go for a different cluster and Kamini will go for a different cluster? No, because it is chargeable. For hosting an application or for having a cluster hosted, it is chargeable. So you would not like to waste unnecessary resources. That is when namespaces come in handy. So namespaces are nothing but virtual subclusters within your main cluster, which is kind of logically independent, but can communicate with each other. So if you even need to communicate with the projects that you're working in, considering you are a part of the same project team, that is also provided, and you can have a number of virtual namespaces in a single cluster. So that would help you in saving up your resources. Again, if you have any doubt or any queries, you can put it in your chat. I would be moving along. Yeah. Next is fault injection using Kiosk Mesh. So let's understand what kind of fault scenarios or what all scenarios can Kiosk Mesh help us administrate. So we can kind of have basic resource faults, we can have platform faults, and we can have application faults. So when I come to basic resource faults, these are basic resource outages or basic resource downtimes, like suppose pod chaos. So what happens in pod chaos? Your entire application is hosted in the pod. So if something breaks down, like your pod is failed for a particular amount of time, or it is killed, or the container itself is killed, so you would be wanting them to kind of having like a new replica should be started up, or the failed container or the pod should be worked on so that it can start up immediately to avoid downtime. When it comes to HTTP chaos or network chaos, there can be a very important chance of latency, right? And in network chaos, you can even have more scenarios for suppose the network packets, the order can be rearranged, you could have packet loss. So essentially, whatever you're trying to communicate won't get along, and something completely different would happen. Apart from that, we also have provisions for DNS chaos, stress chaos, or any other kind of basic chaos faults that you want to administer. Apart from that, coming to platform fault support. So currently, Kiosk Mesh is supporting AWS chaos and GCP chaos support. So if you want to administer any of this platform node reset or stuff like that, it is good to help you. We also have support from application faults, which includes JVM chaos. So if you want to try around with scenario where there is a delay in the function call response, it's good to help you with that as well. Moving ahead, we need to understand the steps that you would kind of follow to have the chaos experiments performed. So the first step would be to define the scope. Obviously, when I would give a very real-time example with it. Suppose you want to test a missile, right? So when we test a missile, there is a damage cause. There is a damage of the, there are radiations, there are things damaged. So you have to kind of cater to a radius or a location with which you would want to limit the damage. That over here is known as blast radius. So suppose if I'm trying to kind of do something on a pod, or maybe kill that pod or kill that container, or maybe we have 10 pods on which we want to kind of administer some scenario, we need to make sure that we have a clear boundary. Whatever will happen to this 10 pods and nothing beyond this, right? That way, if you want to try something, you won't actually break down something you're using as of now. And it would not backfire on you. Obviously, if I'm trying to find an experiment to better my application, I would not want to do something that would actually break down my application. So this concept is very, very useful over here. Next would be scheduling rules. So coming to the fact of scheduling rules. So it's a simple term, scheduling. What does it mean? It means that how you schedule our application or schedule our operations. So what will happen is that if you want a particular chaos fault, probably I want to have network delay every Monday at 11 p.m. Or maybe I want to have DNS chaos every Wednesday at 10 a.m. I could do that readily, because there are no options for us to kind of set a cron job. So whichever time of the week or the day, or whensoever you want to have your applications running, you can do that. Generally, what happens is that we have fixed times where we keep our application down and we try maintenance situations. So you can kind of very well plan it so that you don't cause any outages when you're using the application, and you can very well test your scenarios. Next would be running the experiments. Yeah, so once we have everything in place, we kind of know the scope, we have the schedule up front, we would like to run the experiments. For running the experiments, we have two options that would be exploring more in the coming slides. Once we are done with the experiments, then we'll be kind of viewing the results. So the results would give you a good idea as to where your application is standing as of now in terms of the robustness or the resilience you're trying to work on. And that is exactly which is going to help you to kind of work on what is needed. And yeah, essentially, this is going to help you to build a better application. So again, if you have any doubts, you can put that in. I would be now moving on to how you can administrate fault scenarios using Kiosk Mesh. So as we have mentioned around this terms quite quite some time now. So let's understand in depth what they mean. First is via YAML files. So YAML files are nothing but basic configuration files in which you kind of mention what all actions you want to take place, if there are any data around the same, any specifications, and that will be implemented. Kiosk Dashboard is a feature which the Kiosk Mesh team have come up with. This is a very easy to use, user-friendly and graphically supported virtual dashboard. So you can kind of use this for viewing your current experiments, even creating a new experiment. And if you want to manipulate with anything, stop anything, play anything, yeah, you're all good to play with it. So now we will be understanding the YAML file a bit better. So fault injection via YAML files. So over here, I would need you to understand a few specifications better. First would be the kind of kiosk fault. So obviously, like I have mentioned, for this particular experiment, we would try to target the CIA triad feature, which is availability. So I would try to create a downtime for my application. For that, I would try to kill the pod in which my application is hosted. And I would try to see if a new pod comes up or not. If it does, in how much time, right? So the kind is pod kiosk. The name would be pod kill example. And namespace, as we have already mentioned, it's a virtual cluster. So over here, we have two namespaces. One is kiosk testing and which is another is cluster demo, both hosted in the same cluster. Right? So the action that I'm about to perform is pod kill. There is something known as mode, right? So mode is something which lets you play with the blast radius. Suppose you have 20 pods, which kind of fits in the same namespace. Like suppose I have a namespace, which is TIDB cluster demo, and in that I have 20 pods, right? So I can mention like perform this fault only on a particular pod or maybe any random pod, 25% of the entire total population that you have, 50% or probably all of them. That is exactly what you mentioned when you come to the mode, right? Next, the selector that we have is the label selectors. So label selectors are nothing but key value data that are allotted to every object like pods. So they are basically allotted when you create that object, and they can be altered at any time that you would need to kind of modulate your application. So that can be done. And the key is unique to every object. So a particular object, suppose a pod, could not have two same keys. Moving on, we have fault injection using Kiosk Dashboard. It is probably the easiest way to kind of simulate kiosk faults. So yeah, I think you're gonna love it. So let's see how it happens. So when you open the Kiosk Dashboard, you have options which is called experiments. In experiments, you have option to create a new experiment, or as I've mentioned, you can visualize the current experiments. So over here, we had paused an experiment, which was a network attack, network delay, right? Which is mentioned over here. So we can see all the prior experiments which went along. And at the same time, we have an option to kind of create a new experiment. So probably I clicked on the new experiment, right? Because I want to kind of create a new experiment. What will happen next? Next, I'll be given an option to choose a target. So over here, there are so many options open to me, but as we are currently restricting ourselves to pod faults today, we will be clicking on pod faults. Suppose I clicked on it. Okay, now what is open to me is the option to select any particular pod fault. So I can go ahead with pod failure, with pod kill or container kill. Suppose I want to kill a pod and see how much time it is taking to start the application, or if there is any downtime or not. Here we have one term which is known as grace period. This I won't explain now. While we'll be doing the demo, I think I'll be able to explain it better to you. So just hold on to this for some time. We will go through the other info now. So the other experiment info would be the scope. In scope, we have namespace selectors. As I have mentioned, you can have n number of namespace in this cluster. So over here, our application is hosted in the default namespace. I would select that. Label selector, again, you can see down in the target plots preview, you have the name, right? Over there, web show is present. So I'll be using this particular key value pair as my label selector. So app should be equal to web show, and we selected that. Next would be metadata. Metadata is nothing but the name of the experiment. You can have it pod kill demo, whatever suits that conveys what you want to perform. That is good for us. Nothing specific around the same. So runtime, run over here is basically like, suppose you want to fail a particular pod. How long? Like you can't, have a pod failed indefinitely till the end of the universe, right? You probably want it to fail for like few seconds, few minutes, or hours. So you have all possible duration format available over here. You can have milliseconds or seconds or minutes or hours. Just mention the number and give the SI unit which fits perfectly as per your requirement. Cool. So now that we have a better theoretical idea on what chaos engineering is, what chaos mesh is, and yeah, important components regarding chaos mesh, we would be doing a live demo wherein you will be kind of simulating pod kill chaos using chaos mesh. The best part is you can do it right now with me. You won't need any setup, nothing. It's completely open source. So you can just search with me as I'm doing. Go to Google, search for chaos mesh, and click on interactive tutorial, and this is what you will be having in front of you. So it is a difficulty level beginner. So yeah, it won't be much difficult to work on it. Estimated time is 15 minutes. So I think this is, you can something which one easily, give. So yeah, you can just do it right ahead with me only. So what we will do in this particular experiment is that we will be installing chaos mesh onto Kubernetes cluster. So you have already have a Kubernetes cluster hosted for you. You just have to install chaos mesh onto it, install and label applications to make them eligible target for chaos. Like we mentioned, something around blast radius, select the target for your experiment and then perform the experiments. Design and deliver chaos experiments. Whatever experiment you want to go ahead with, you can design it and then deliver the experiment. For delivering, we'll be using Kiosk Dashboard as well as the config YAML files. So the last would be observe the chaos engine exercise or experiments against the cluster objects. Obviously, any experiment has some observation leading to it. So after you're done with it, you can observe the results that we had. So now we will be clicking on the start button. So what is mentioned for this lab, we have already started a fresh cluster for you, which is great because we don't have to pay for it. It's readily hosted by the Kiosk Mesh team. Just click on it and your Kubernetes master is ready and your cluster is ready. So Helm package manager is something that we'll be currently using for installing applications on Kubernetes. So let's see if we already have that and the version that we have with us. So we already have this version with us. And I'll be going to the next option. Next step would be to install Chaos Mesh. So add the chart repository for the Helm chart to be installed. I would do that. Check on the version and then install Chaos Mesh. Done. Now let's. Okay, so what did I do right now? I entered this command kubectl get pods namespace chaos mesh, right? Get deployments pod services namespace chaos mesh. So we are mentioning we want to get into the namespace what chaos mesh, and in that what we want to get the deployments pods and services. So what all pods do we have? Like we have mentioned, we have our controller manager, which is helping us for scheduling the application. We are having the chief executive component, which would hack into the namespace of the other pods and kind of induce your experiments. We have Kiosk daemon over here, and we have our very friendly Kiosk dashboard with us. So now that we are all good, we can kind of move on to the next step. And there is a link for opening the Kiosk dashboard. So it's that user friendly actually. If you have already an experiment schedule, you can see that. If you have any schedule set up, you can see. Workflow basically is a scenario. Suppose you want to have a complete test of your application. So you would be like, okay, first perform pod chaos, then go on to DNS, to HTTP, and then close with a stress chaos. So it will build a complete workflow for you, and you can easily see the entire resilience of your application. So over here, we have workflows, we have schedules, and we have experiments. So let's start with a new experiment. But for doing that, I would need to host an application first, right? So that is also something which Chaos Mesh would help us. So yeah, just a demo for all type of all type of experiments that you have. So you can go through them. That would help. Coming up, we would be installing our application, which is a WebShow application, which is also kind of supported by the Chaos Mesh team. So I would just be following the application. I would be applying the deployment and the service files. And our web show is created. Now we want to get the deployments, pods, and services. So what do we have? We have one deployment and we have one pod which is up and running. Over here, you can see one thing that the current status is like we are checking how many pods are ready. So we have 0 by 1. So what is happening is that container in it is still creating. So you can kind of check the status of the pods also, like if it's ready, or if it's creating, if it's terminating, what is going on with it, right? The age and everything that you want to get about. Now that everything is good, let's go ahead and create a new experiment. I would select pod fault like I told earlier, and I would go to pod kill. This I'll be saving for last. So yeah, right now I will not be giving any this period. I would just submit it as a versus. Yeah. So namespace, our application is hosted in default namespace. We click on that. Our application has this label selector web show. We click on that as well. Mode is just one, so I'll go with all probably. Metadata, I think pod kill would suffice. Again, we don't have a duration because it's just about killing the pod. I don't think there is any role of duration over here. If you want to perform a particular fault for a particular scenario, then this kind of helps. So as of now, this what should do. And what did I do? I clicked on it and it shows me finished pod kill, created successfully. So if I click on that, what do I see? That this experiment has been administered. It had a definition, which means that kind of, again, the same kind of YAML file that we saw. So it mentions the same thing, the kind of kiosk, the name of the experiment, the namespace on which you should administer the experiment, and we should have the name of the application on which we're performing it, label selectors. We have all selected because we want to kill all. Action is pod kill, grace period is still a suspense. So let's go ahead and see how do we kind of see it from the terminal. So there is a command, kubectl, which kind of helps you understand the status of Kubernetes objects. So if you see over here, if I do get pods, what do I see? I see one pod is still there, but is it same as the pod that we had earlier? No, it's a different pod. And the age of this particular pod is 48 seconds. So what happened is that the earlier pod that we had got killed, and in its place, we have a new pod coming up, right? So now that we have understood this, we should go back to one thing that we have kept in pending. That is grace period. So let's see what happens with that. Again, the same steps. Over here, I'll be giving 30-second grace period. I will also tell why did I choose 30 seconds only. So namespace would be same, default label selectors would be same. Mode again, all works for me. Pod kill one probably. Again, duration has no roles. Submit and submit. Created successfully, is it? So again, we have the same data, only change. I think this is changed. It's a grace period. We have 30 mentioned. Now, if I kind of come up over here and mention the same command that we did earlier, what do I see? Just give me a sec. Yeah. So it is a new pod. So what happened is that when you give this thing called grace period, it basically gives you a certain amount of time before you kill this application, kill this pod. So suppose if I have a pod, what would happen in that pod? The pod would be having a container, right? And if you would suddenly go ahead and kill it, there would be requests coming to it. And then at the same time, it would be rendering some services as well. So if you straight away go and kill it, the operation that it would be currently doing would be kind of incomplete. So what we generally do in Kubernetes is that we give it a 30-second period where we lead it when we allow the pod to be killed gracefully. So it is a period where the pod is called as terminating, and whatever is running in that particular pod will be executed, but no new requests will be coming to that pod. So the pod would get enough time to kind of execute whatever is going inside that pod, and you would kind of get a graceful execution. Again, it depends from situation to situation. If you want to kind of, create the scenario wherein you probably would want to see how your application reacts if you give it a grace period, and if you don't give it a grace period, in that case, it will come very handy. So now that we have one pod running, what we would be doing is that we would be going ahead and try something with the YAML file. So yeah, now that we have used our dashboard for administrating kiosk calls, we also need to check what happens if we use the YAML file for the user. So you would be clicking on this, which gives me an idea on what is currently present in the network delay experiment.yaml file. So it is similar to what we have already seen, just that you have the mode, the application you're running the kiosk fault on, and you have the namespace on which you're working on, and the action. So over here, the action is delay. And for how much are we delaying it? We are providing a 10 millisecond latency. So I think that works. So what I will do right now is that I will just go ahead and apply. That is administered. Now, how do we check that? Again, our dashboard. So if you go refresh it and see, there is another attack present over here, which is known as the network attack. So basically, you have two ways to kind of administer your attack. If you just want to use the dashboard, you can do that. If you kind of want to use the YAML file for doing it, you're good with that as well. So I think that would wrap up the scenario for this demo. Yeah, if you have any doubts or any queries around this, you can feel free to kind of express it, because we're going to have a Q&A session now. So do we have any questions, any queries? If not, I would be handling it over to our host.
Also, before we end, there is a link pasted in the chat for feedbacks. We would love to have your feedbacks so that we can learn more, learn better, and do better in our upcoming vodka sessions. It will be very helpful if you would provide your valuable feedbacks through these forms. Thank you. Over to you, Jasleen.
Yeah, thanks, Kamini. Thanks, Ritu. A wonderful talk. As Kamini mentioned, please put in your feedback in the form given. I will hand it over to Jayashree for closing the 21st edition of Vodka. Over to you, Jayashree.
Yeah, thank you, Jasleen. And thank you everyone for joining in on a Friday evening and giving so much of your time to learn with us and share. We would like to share whatever we learned in this past time. So yeah, this was 21st Vodka, and we are very privileged to being present that to you. I'll start with my introducing myself. I'm Jayashree Vardar. I'm QA community lead for Gurgaon, and I've been in ThoughtWorks from last 5 years, and I've been in industry from around 11 years now. Have worked with various types of project, and ThoughtWorks also I've worked with various things. So it's a very lucky journey for me here. So yeah, also I wanted to talk about, like, today's session. We talked about Playwright, we talked about chaos engineering, chaos mesh, a lot of niche topics which are currently in, like, a lot of people are being using, and Playwright have such good features. So even after the session today, I would like to work with the Playwright. It has very good on the box features which are available out of the box, which you need to do a lot of work in order to integrate with your frameworks. And also we talked about security. If you want to go into a security project, we talk about the basic things as well as how you do the chaos testing as well in various forums. So yeah, and please, we believe in having feedback culture. So please give your valuable feedbacks. It will help us to improve and give you more refined sessions next time, so that we all can benefit together and learn together. It was really very nice of you to join in and give your so much time to us. And the recording of these sessions would be available on our YouTube channel, and it would be shared by the summary email, which is being shared by the organizers. So yeah, looking forward to see you in the next Vodka as well. Meantime, just keep learning and sharing with everybody. That's it. Thank you so much. Over to you, Jasleen.
So yeah, for now we can unmute anyone who wants to ask anything or wants to have a chat maybe. So yeah, go
Even
ahead.
feedback would work.
Yeah, even feedback would work. Anyone would like to go ahead? We can unmute you and we can talk.
In case you want to ask any questions or to provide any feedbacks, maybe you can raise your hand and then you can unmute your.
I guess the talking is permitted to everyone here. If anyone wants to talk with us, please unmute yourself and feel free. Okay. Waiting for 1 more minute or else we can close this session.
I think we can take silence as agreement. Everyone's just immersed with whatever knowledge we've had over the period of last 3 hours. And thank you for all the speakers and the participants to be part of this.
Okay, then thanks everyone. See you in the next vodka.